Hello, we are Team O and we are excited to present our findings to you for this project. Do you know how many letters and packages are picked up and delivered each day by United States Postal Service? The number is 509 million. Do you know how these letters are classified? Sadly, to read the postal code on these packages and classify them correctly is a manual process. The problem is that the task is redundant and takes huge amount of time and labor. We plan to save millions of dollars spent on manual classification of numbers in many industries such as banking and postal services. Imagine that USPS currently classifies its 509 million letters manually, and let's say on average it takes 5 seconds for an employee to read and classify a postal code. Well, this translates to approximately 700,000 man hours for this task. That is a lot of time. That's when our model comes in to save these enormous hours and related costs. Our data comprises labeled images of handwritten digits represented using 256 pixel intensities. Our aim was to use this data to create a model which correctly classifies the digit by reading its pixel intensities and thereby remove human intervention. First, we plotted digital images by taking means of pixel intensities in the data for various digit classes and found that our data represents the actual digit classes very accurately. This gives us the confidence in designing our classification model with great accuracy. Then we ran our data through HOG algorithm to get 1764 extra features from each digit sample. Using this, we leveraged intensity gradients and edge directions to increase the accuracy of our model. We also ran principal component analysis to observe how much variation is present in our data. Using the train and test data given to us, we performed hold one out validation on models such as support vector machine, k nearest neighbor, random forest, naive Bayes, decision trees, and classification trees. By plotting the metrics for these models, we noticed that naive Bayes, decision trees, and classification tree have highest misclassification rate. So we decided to remove them from our consideration and went on to explore the remaining models further. For k nearest neighbor, we found that the value of 3 is an optimal number of neighbors to be used in the model. Also, when we compared SVM against random forest, we found that though their accuracy is close to each other, but random forest is computationally expensive and takes around 50 minutes to run. Considering this along with many other metrics, we decided to drop random forest model for now. So we went further and started to tune the model which performed the best amongst all, SVM. We also ran SVM across k-fold cross-validation with a range of k values to avoid overfitting. We kept a high threshold of 90% so that our model refuses to classify those digits which are not clear. Keeping this threshold for SVM, we used a kernel function such as linear, polynomial, radial, and sigmoid. We found that SVM tuned with linear kernel function gives the best performance. We also tuned different hyperplane parameters for this model to avoid underfitting and improve the accuracy of the model further. Our finding was that SVM model gives the best performance with accuracy as high as 99.6% and rejection rate of 9%. This means that our model will refuse to classify 9% of the cases, which would then require human intervention. Now you might be wondering, why did we keep a threshold of 90%, which resulted in this human intervention? We did this because we understand the criticality of the business operations that our model can be used in. Imagine using this model in banking operations such as reading the account number on a check which is due for deposit. We cannot imagine a model which has a low accuracy because the resulting implications will be disastrous. We have tuned our model keeping these performance measures in mind so that our model gives an amazing accuracy. At the same time, we give the freedom to our client to decide their threshold value so that they can choose how much accuracy they need versus how much manual intervention is appropriate. Going back to our USPS example, if our model is used to classify digits, we can anticipate that approximately 697,000 hours of work will be saved, which is a great reduction. Also, if we take an average expense of $15 per hour, this translates to approximately $10 million savings every day. Amazing, isn't it? So we would like to conclude by offering a model which is based on SVM algorithm, has an accuracy of 99.6% with a threshold probability of 90% and a rejection rate of 9%. One of our next steps is to incorporate various heuristic approaches to reduce the rejection rate of our model even further. We will also explore tuning additional parameters for random forests once we have good computational resources at hand. And we also look forward to deploy our model in few real-world business operations and anticipate to see drastic time and cost reductions. Thank you for watching our presentation.